Abhinav Kumar is already joined. Good afternoon, sir.
Good afternoon.
Uh, Let me just briefly introduce Dr. Abhinav Kumar. Uh, he is currently working as an assistant professor in the Department of Computer Science and Engineering uh, at Motilal Nehru National Institute of Technology, Allahabad. Prior to joining MNIT, he also worked as an assistant professor at the uh, Indian Institute of Information Technology, Surat, as well as Shiksha Anusandhan, Bhubaneswar, Odisha. Okay. He has obtained a PhD degree in Computer Science and Engineering from the Department of Computer Science and Engineering of the NIT Patna. His research interests include machine learning, deep learning, crisis informatics, natural language processing, and social networks. So he has also published various journals such as IEEE, TII, Neural Computing, and Applications. So, with this brief introduction, we would like to welcome you to the session, the FDP on deep learning, sponsored by ENICT MNIT Jaipur. So, I welcome you to the session, sir, and over to you.
Thank you. Thank you. Should I start now?
Sure, sir, you may start.
Fine. Fine.
What is
Thank
it?
you.
Oh,
So first of all, I'll try to share my screen. Just let me know my screen is visible or not. Uh, just hold a minute. Just check it once. My screen is visible.
yes, sir, it is.
Fine.
Yes, sir.
So I'm starting. See. So today's topic of discussion is I just try to discuss different topics related to word embedding techniques. Okay. So in the natural language processing, we have text, different text. We have you can say the speech signal. We have a text. So how we are actually try to convert text into the vectors, which is a very important topic. Okay. So if you are dealing with, let us suppose, any image. So in the image, if you will read this image, so you are going to get directly pixel value. So pixel value, if you are directly getting pixel value and you are, let us suppose, reading any image, so you are going to get the pixel matrix. So if you got the pixel matrix, so directly you can apply different deep learning concepts like CNN, convolutional neural network, or you can apply different, you can say the recently very popular network like Vision Transformer, that you can apply directly on the pixel matrix. But the thing is that if you have a text, so let us suppose this is the classroom. So how you are going to utilize the text and how you are converting this text such that we can apply different deep learning or the machine learning concepts. So for the today's discussion, I just try to discuss various, you can say the word embedding techniques available, and I will try to go from basic to advanced level. Okay, so if you will look at, and then for the entire discussion, I will go through only Google Collaboratory because entire content, I just included entire content here only, such that what I will do after discussing any of the topic, whatever the topic I will discuss, along with this one, I will give you live demo also. So after discussing about the concepts, how this concept can be applied and how you can utilize this concept, that we are going to discuss. So I have not prepared any separate, you can say, the slides. So from this notebook only, I just try to explain everything. Okay. So first of all, one question is why this embedding is required. So as I said, you have to somehow convert text into the vector. No, fine. So there are different things. If you will try to give you one example, Bank of River or the, let us suppose, State Bank of India. Okay. So in both of the sentence, the Bank of River or the State Bank of India, we have a bank word. No. So bank word is common. So we have a different, you can say, the embedding techniques by which we can convert this bank word into its corresponding vectors. Okay. So some of the previous techniques uses the different, you can say, the techniques that convert this bank as a vector. In those previous techniques, this bank, the vector, the embedding vector for the bank will be very similar. Okay, so you can say the same type of vector it will assign. But due to the advances of different, you can say, the word embedding techniques like BERT or the Elmo. So it just try to get the context of entire, you can say, the sentence. It will try to give you the different word embedding vector for the same word bank based on the context. So those type of things we are going to see. So if you will look at this table, so we have a different type of word embedding techniques. If you just look at this, you can say the table. So we have a one hot vector, we have TF-IDF, we have a word2vec, we have a Globe, FastText, Elmo, BERT, Robotta, ExcelNet, and different many more. You can say the word embedding techniques we have. So for this session, at least I will try to cover from this basic word one hot vector to at least BERT embedding vectors. Okay. So based on the availability of time, we'll see how much amount of content I just try to cover. Okay. So based on the availability of time, we'll see. So first of all, I'm starting this one hot encoding vector. So see, one hot encoding vector is a very, you can say, the basic technique to convert text into the words. Okay. And nowadays, if you will go into the depth of, you can say, the SIBO model, the SkipGram model, or we have a different, you can say, the fast text model. Those things we are going to discuss. Okay, don't worry right now. I'm just trying to take some of the names like fast text or the SIBO or the SkipGram. So on that one also, we are representing a word into the one hot vectors only, encoding only. That due to this, we should have to know what is this word one hot encoding, and then we will try to go into the you can say the more advanced models. So if you look at the example, so entire thing we are going to discuss with the example only. Okay, so that will be more meaningful and that will be more understandable. So if you will see this example, so we have a cat, dog, fish, bird, and lion. Okay, this is, let us suppose, one vocabulary you have, and I want to convert this cat or the dog or the fish, bird, or lion into the one hot vector. So one hot vector means what? If a word is present now, it will be 1, otherwise it will be 0. Meaning is what now? So if you will see representation of this cat, so I'll just try to zoom it further. So if you will see, sorry, if you will see this cat, meaning is what? Now this cat, so index is 0, 1, 2, 3, and 4. So at the index of 0, if you will see, we have 1. It means what? The cat is represented by a one hot vector 1, 0, 0, 0, and 0. Like that one, let us suppose this is a bird. So bird is present at the which index? 0, 1, 2, and 3. Third index we have word. So let's see. The third index value we have 1. So likewise, you can convert text into one hot vector. Okay. So for this one, I have included one demo also. So if you will see the entire code, and the coding is very easy. So I always try to use the sklearn library. Along with this, when I will go to the BERT or the Elmo method, I will use either TensorFlow or the PyTorch. Okay. So if you will see, so this is the corpus we have, whatever the corpus we just discussed. And we have this one hot encoder, and we are just fit transfer. We are doing this fit transform in the corpus, and we are going to get one answer. So I just try to run this code for you. If you will see, yeah, just hold a minute. I just have to connect this with my collaborator. Just hold a minute. Yeah. If I will run this code, and one more thing, I will discuss entire thing one by one. But whenever you will get any difficulties, no, so you can interrupt me. We will discuss more on that topic. Okay. So yeah, now if you will see this code, now entire you can say the corpus is converted into the one hot vector. Okay, we just discussed about this one. Wherever you have the word, it will be represented by 1, otherwise it will be 0. So like that one is converted into the one hot vector. This is a very simple example. Okay, now after discussing this one hot vector, next is count vectorization. Okay, so what is this count vectorization that we just try to discuss? So count vectorization means what? Now, irrespective of only 1 and 0, we'll just try to count the number of occurrences of any word. Okay, so how much time this word is occurring in the document. For example, if I will take one example, let us suppose we have a three different, you can say the text. I love machine learning is amazing, and the third one is I love deep learning. So what you have to do, we have a three different sentences. So what you have to do, you have to create a bag of word. So there is a concept bag of word. So this bag of word means what? You have to include unique words in that bag. So meaning is what? So if you will see, I love machine learning, you have a four different words here. And machine learning is amazing. You have again four words here. And I love deep learning. Again, you have four words here. So in the bag, if you will see, you have the unique words only. So I is occurring here also, here also. But in the bag, it will be represented by only one occurrence. It means what? The bag will be the collection of unique words present in your corpus. Okay, so this is the bag. And now, based on this bag, we will try to uh, create the or the generate the count vectorizer for any sentence. So how, just see. So now if you look at this table now, so I love machine learning is amazing deep. So this is the total, you can say the uh, corp, bag of word we have, and this is the sentence now. I love machine learning. So I love machine learning means what now? So it just try to count the number of occurrences of that word. So I is occurring how many times? One time. So just see, I is one. Love is occurring one time. This is one. And similarly, if you will see, uh, in each of the sentence, do not have any more occurrences. Okay, that's why it is a 0 1 only. But in your example, I have added one more thing. Just if you will see this entire code now, I have added this one now. So I love machine learning and I love learning classification method. So if you will see this text now, so this machine is one time, love is now two time, I is now two time. So likewise, you have to represent the it into the count vectorizer. So for that one, we have a count vectorizer. We are doing the fit underscore transform. At the last, we are printing the count vectorizer only. So if I will run this code, just see what type of output you are going to get it. Yeah, now see. So just wait. Yeah. If you will see, this is the corpus we have, and this is the bag of word. Okay, so this is the unique words we have in the bag, and this is the count vectorizer. So see, the love is here and learning, love is here, fine. So love is here, love is occurring two times, no. So index is 0, 1, 2, 3, 4, 5, 6. At the sixth index, you have occurrence of 2. So now see 0, 1, 2, 3, 4, 5, 6. So this value is now for love. And this value is for now machine. So likewise, it will just try to convert text into the count vector. So meaning is what? In the previous one hot vector, we are just seeing occurrence of that word in the sentence or not. So it will be binary type only 1 and 0. And the count vector, we have a number of times that word is occurring. Okay, so likewise, we can convert it into the count vector. So after converting this count vector, the one hot embedded vector, you can apply some basic machine learning algorithm like SVM you can apply, random forest you can apply, that you can apply. Okay, so that we'll see later. And after this discussion, we will move into the third part, TF-IDF vector. So now if you have a text, so how you are going to convert it into the TF-IDF vector? TF-IDF means what? Term frequency inverse document frequency. Okay, so it's the term frequency inverse document frequency. Now, in the previous case, we just taken the account, no? So how many times the word is appearing in the sentence. Now, what this TF-IDF will do, it will not only count, but it will also normalize that value. How? See, the TF value for word W, if you will see this formula now, it is a number of times word W appearing in the document, appears in the document. So in the previous case, if you will see in the count vector, we are taking only numerator value 1. but now we have a denumerator value also, total number of words in the document. So that we have to also do. And in the IDF means what? So it's a log of total number of documents divided by number of documents containing word W. What is the meaning of this one now? So see, I just try to take one example and will show you what is the different advantages of this TF-IDF on word to weight, count vectorizer and one hot encoding techniques that we are going to see. So again, I just try to take one example. If you have to calculate the TF-IDF factor, so what we are going to do, we are multiplying this TF value with the IDF value. So now what this IDF value will do with this TF, that we are going to see. Okay, so just hold a minute. So again, we have three same example we have. So I love machine learning. Machine learning is amazing. I love deep learning. Okay, so you have again a bag. Okay, so bag of words you have, and now this is the term frequency. Term frequency means what now? So term frequency, if you will look at the formula, number of times word W appears in the document divided by total number of words in the document. Meaning is what? If I have to calculate the TF value for this I, so it will be 1. So this I is occurring one time in this document divided by total. So total is 1, 2, 3, 4. So it is 1 by 4. Okay. So likewise, you can calculate the TF value for each and every word. Now the fine. So we are easily able to calculate the TF value. Now what is the role of IDF? Now just look at the IDF calculation. So if we will calculate the IDF, so what is the formula of IDF? IDF is log total number of documents divided by number of documents containing word W. No. So now if you look at this table, in this table if you will visualize, so if you will calculate the value for this IDF value for this so it will be log 3 by 2. What is the meaning of this 3 by 2 now? See, 3 means what? Number of documents. So number of documents is 1, 2, and 3. Fine. So in all the 3 documents, how many times this I is appearing? So if you will see in the first document and the third document. That's why the value is log 3 by 2. So this is the IDF value of I. So likewise, you can calculate the IDF value. And final calculation will be done based on what? Multiplication of TF value with the IDF value. Now, I just try to uh, take one example of this learning. If you will see, learning IDF value is 3 by 3. Why? Because this learning here, here, in the first document, in the second document, in the third document. So in the entire document, we have the occurrence of this learning. So that's why IDF value is 0 now. And if I will tell you to calculate the TF IDF value for learning, so what you will do? So you will take the TF value for this learning and it will be multiplied with the IDF value of this learning. It means what? You are going to get TF IDF value equal to 0 for learning. No. So what intuition we are going to get it from here? So see, in real life, if you will see, the occurrence of the, on is frequently throughout all the documents. No, and let us suppose you have a classification problem. So in the classification problem, if you will see, is the and these things are not giving us any value in terms of, you can see, the segregation of the things, because these terms are appearing throughout all the documents. Meaning is what? What this IDF is doing now? IDF is trying to minimize the value for the words which is appearing throughout every document. No. So this is the intuition from this IDF. It means what? A word which is occurring throughout every document, then for that one, we are going to get lesser TF IDF value. And it helps during our NLP task. So whatever the task you are doing, if the word is not very much important for your task, it just try to give lower value for this TF IDF. So this is one of the advantages, you can say, of this TF IDF. But one more important point I just tried to mention. So in this case, if you will see, we are creating bag of word. No. And if you are creating the bag of word, and if you are creating TF value, IDF value, or the one hot vector value or the count vector value, it not preserve any sequence. Meaning is what? If this is a classroom, it is not preserving is a classroom. It means if before this classroom we have a, it is not preserving. It means what? It just created a bag of word. I just try to give us the entire vector based on the bag. Now the problem is that it not preserve any contextual information. Due to this, different n-gram features are there. Okay, so different n-gram features are there. So what I will do, I just try to run one code for you for this TF IDF. Then I will move to the more advanced techniques like word embedding vectors. Okay, so if you will look at this example again, first of all, I just try to show you this is the corpus. Okay, fine, and this is the TF-IDF value. So I just try to first modify 1, 1. So what is the meaning of this 1, 1? And I'll just try to run this code for you. Now see, this is the bag, fine, and this is the TF-IDF representation. Now fine. So if you have an n-gram range 1, 1, it is taking one word at a time to create our corpus. But now, let us suppose I just try to put this 2, 2 now. So what it will do, it will now take two words at a time to create the corpus. Meaning is what? I love, this is the first. So love machine, this is the second. And this is the machine learning, this is the third one. Okay, like that one is just try to create the corpus. But it will be in the sequence, not like it is I and learning. So it will be in the sequence with the window of 2 only. So now if I will run this code for you, now see the bag or bag. This is deep learning, is amazing. Learning is, it means what? So two word is now appearing. Okay, so for creating our bag of word. So like that one, it's just trying to preserve some sort of context, but not entire, some sort of context. Okay, so likewise, if you have this 3, 3, so it will just try to take the embedding vector from, just see, so 3 word at a time, 3 word at a time. Like that one, just try to create the TF-IDF representation. Okay, so this is the concept. And one more important point I just try to discuss. So here I have used TF-IDF vectorizer, which is I have taken from sklearn library. But whatever the concept I just discussed, no. So total number of document divided by, sorry, number of times the word is appearing in the document divided by total number of document. So that one is written here only, if you will see. Okay, and if you will run this code, no, you are going to get some different answer. Okay, in comparison to the previous code, if you will see, we are going to get some different answer. The reason is that in the sklearn library, is just try to normalize the vector such that the entire vector value, if you will sum up the entire vector value, we are going to get the 1 as a total summation for each and every sentence. So that's why, so this normalization concept is in the sklearn library. That's why we are going to get some different answers. So you do not going to get confused related to this concept. If you will also apply this normalizations, you are going to get the same answer. Okay. So these are the different, you can say the discussion. Now after this many discussion, so this word to vec technique. So this one hot encoding vector or the count vector or the TF-IDF vector. These are the different techniques we have, and this is, you can say, the very old techniques we have. But now, what this word to vec is doing? Okay, so word to vec is doing. So just see. So what we will do, we will try to convert text into the equivalent vector. Okay, so how we are going to convert it into the equivalent vector, that we are going to see. So now, word to vec means again. So again, it will represent the entire sentence, entire word into the corresponding vector. Okay, and for getting the word to vector, two different popular techniques we have. Okay, in the literature, if you will go into the literature, two different techniques we have. So one is continuous bag of word, and another one is skip-gram model. So what is the meaning of continuous bag of word? What is the meaning of skip-gram model? That we are going to see. So in the continuous bag of word model, so again, I just try to go into the explanation part by just showing the visualization. Okay, so what we are going to do. So first of all, I'll just try to show you this diagram. If you will see this diagram now, let us suppose you have this word, the cat sat on the mat. Okay, so this sentence you have, and what we are doing in the continuous bag of word model is just try to take a window. Okay, a window means surrounding words, you can say. So meaning is what? If you will see, if we have a window size of 2 and the context word, let us suppose we have a cat. Okay, so we have a cat and we want to take the surrounding words. Okay, so this is cat here. So window is 2. So two word we are going to get it from left and two word we are going to get it from right. Okay. So if you will see only one word we have here. So the and sat on, two words we have after this cat. So this is sat and on. So this is the context word you have. So similarly, one table I have represented here. I just try to zoom this table, zoom it this table. So if you will see context word and target word. So target word, let us suppose you have a cat and window size, if I will represent this window size is one only. So one word before this cat and one word after this cat will be the context word. So this is the sat is the context word. Similarly, let us suppose sat is the target word, then this cat and on will be the context word. So like that one, you are going to get one context word and one target word. Now what this SIVO will do? So SIVO will just try to put the different word value here, different word value here. So from x1k to x2k dot xck, and it just try to predict that word. It means what? Based on the contextual word, it just try to predict the target word. And this will be the concept of neural network only. Okay, it means what? This x1, x2, x3, x1k or 2k or 3k, first it will be represented in the form of one hot vector. Whatever the topic we discussed the first at our start. So one hot encoded vector. So this is the one hat encoded vector. This is the one hot encoded vector. Again, this is the one hot encoded vector. And based on the context, we will try to predict the target word. And whatever the weight we are going to get it and the hidden layer after entire training, that will be our embedding vector. Getting my point? It means what? Based on the context, you just have to predict the target word, and whatever the target word after entire training of your corpus, whatever the value you are going to get at the hidden layer, that will be your embedding vector. Okay. So this concept we have in this SIBO. It means continuous bag of word model. Okay. And for this one, I have also included one demonstration. So I just try to show you the output of this demonstration. If you will see, we have this corpus. We tokenize this sentence. I think tokenization you know already. Tokenization means what? We just try to tokenize entire sentence into word wise. Okay. So after that, we have a word to vec model. We have a tokenized corpus and vector size. It means what? Vector size equal to 50 means it is saying about this size, in which size you want the vector. Okay. And after that, we have a window size of 2. Window size of 2 means what? Two words before the target word and two words after the target word. And minimum count is 1. So minimum count 1 means what? If a word is appearing at least one time, then we are going to take this one. If let us suppose someone will specify minimum count equal to 3. So if a word is appearing at least 3 times, then only it will take the account and it will try to train the model. Otherwise, they will just try to skip those words. Okay. And after that, SG equal to 0. SG equal to 0 means what? This is SIBO model. If SG equal to 1, this is a SIBgram model. So I will discuss that one also. Okay. So after this many things, we are printing this vector. So now see, this is the vector of this is the vector for this cat, and if you will count the entire value now, that will be 50 because we have taken a vector size of 50. And after this one, we are printing the most similar word related to this cat also. So now in this corpus, as we have a very less amount of, you can say, the sentence, only 4 sentences we have, And based on this sentences, if I just try to find the similar word related to this cat, so this is barked, this is friends, this is carpet, this is a similar word to this cat. But the thing is that we have a very small purpose. Now, when I will uh, load some pre-trained model, no, then I will show you how, if we will print the similarity between king and queen, so how the things are going to happen using the uh, word embedding vector. So the entire target of the word embedding vector is that if we have a similar type of representation of the word, it means what contextual meaning. Let us suppose you have a good, bad, and worst. Three words we have: good, bad, and worst. So if we will have the embedding vector of good, bad, and worst, so the difference between good and bad will be higher compared to the difference between bad and worst. So we have to generate a word embedding vector in such a way, such that we can preserve some meaning of the word. Okay, so that I will again explain. Okay, so when I will load some pre-trained models. So this is the explanation related to SIVO model. And if I will move to the skipgram model, no. So skipgram model means what? This is just the reverse of, you can say, the SIVO model. Just the reverse of SIVO model means what? In the previous case, if you will look at the diagram, so we are going to predict the target word based on the context. No. So what we are going to do in the skipgram, it is just reverse. So what we are going to do, so this target word, based on this target word, we are going to predict the context. This is just the reverse of the previous one. And this is the skipgram model. And again, this, whatever the value we have here at the hidden layer, the connection from this hidden layer, that will be your embedding vector. Now, if you will look at this explanation, so again, the same window size, entire thing is same, just reverse. The training is reverse only. Okay. So again, if I will show you the answer, so this is again same corpus, and now we have a SG equal to 1. It means what? Now this is the skipgram model. Okay. So in the previous code, if you will see, we have a SG equal to 0. So this is a SIVO model. Now this is a skipgram model. I just try to show you the output. If you will see, again we have the word embedding vector for this cat. It is represented by a 50 value, and similarly, similar word to this cat, again we have a bark and like that. Okay, so meaning is what? If you have your own corpus, so for your own corpus, you can create word embedding vector using SIVO technique or what to, skipgram technique. So you can generate. And that embedding vector, it means what? Let us suppose now if I will say this is a classroom, so now you know the embedding vector for this, for is, for a, or for classroom. Now if you are going to get the embedding vector for the entire word, so now directly you are going to get what? One sentence matrix. This, for this you have a one, you can say the embedding vector. For is you have one embedding vector. For a embedding vector, and for classroom you have again one embedding vector. So it means what? Now you are going to get the sentence matrix. Now if you are able to get the sentence matrix, then I think in the previous classes this LSTM or the BiLSTM, CNN, these type of concepts are already covered, I think. So what you have to do, so if you are able to convert it into the vector form, matrix form, so that matrix you can now directly utilize for any LSTM model or the CNN model to extract the features, or you can try to learn the features from the embedding and try to do your task, because it can be a task of classification or regression or the clustering. It is based on your task preference. Okay, so that you can do. So now after this many discussion, I will move to the pre-trained embedding vector. As I said, we have several pre-trained embedding vectors also. So one of the pre-trained embedding vectors we have from GLOVE, GLOVE, and that is generated by Stanford University. Okay, so I will give you one demo related to that one also. And one is we have a FastText. FastText is developed by Facebook Research AI. Okay, so Facebook AI Research. So this is developed by Facebook, and one is developed by Open. You can say the Stanford University. So what I will do, I just try to show you. Like if you will see in this code. We have a word to wake Google News. So this is trained on the Google News with the 300 dimension. So here what we are doing is model king. We just try to get the embedding vector for this king, and after that we just try to print the first 10 values. So if you will see, so this value we have now from the pre-trained embedding vector. So what is the difference between your on embedding vector? What is the difference between your pre-trained embedding vector? So as I said, you have a SIBO model as a scriptgram model. You can directly create your own embedding vector. But the thing is that if you have a very less amount of corpus, let us suppose you are working on the fake news or the sentiment analysis or the, let us suppose, rumor or the sarcasm detection, you have, let us suppose, 20,000 tweets or 20,000 social media posts only. And if you are trained your model with the 20,000 tweets or the samples only, so it may possible that the global context of the word will be missed from your basically calculation. So what people is doing, people just try to use the pre-trained embedding vectors also, because this is trained on the huge corpus. Okay, huge corpus, billions of corpus. Okay, so it means what global context will be preserved in that, you can say, the embedding. So it is on the, you can say, the users only. Somewhere if you will see your own embedding is working well, somewhere your pre-trained embedding is working well, so it will be based on the, you can say, the problem statements. So now again, if you will see a most similar word to this king according to the, you can say, the word to wake Google News corpus, so you can say the word embedding vector. So now see, most similar word into the belongs to this king is kings, then queen, then we have a monarch. Like that one, you are going to get the most similar word. So similarly, let us suppose you want the answer of king plus woman minus men. So that is also possible. So it means what now? If you are if you are able to represent word into the corresponding vector, so now you know how to add two vectors, how to different basically uh, do uh, minus between the two vectors or the addition between the two vectors. You know, so like that one, you are going to do the operations, and you will get very interesting answer. So king minus men plus woman, just see, we are going to get this queen. Okay, so very interesting answer, you are going to get it. So similarly, most similar word between this, similarity between this queen and king is, so if you are going to print the similarity, so it will be 0.65. So the similarity is higher if you will say. If you have some other word related to, let us suppose, car or something, the difference between the queen and car will be very less. Okay. So like that one, again, we have one odd one out. If you will see, the king we have, queen we have, apple we have, a prince we have. So in entire four words, if you will see, which one is the odd one out? So odd one out is this apple only. So apple will be odd one word from this entire, you can say, the uh, whatever the values you have. So this will be the odd out. So that also you can achieve through the word embedding technique. Okay, so this is the answer. So similarly, we have the Paris minus France plus Germany. So you are going to get the different answers. So likewise, I just try to say, so different operations you can do between the embedding vectors. Okay. Now, one more important point, I just try to plot the word into the two-dimensional space. So I just try to plot it into the two-dimensional space. Okay, fine. So I have to run this one. No, just wait a minute. So hold a minute. It will take at least 30 seconds. Just wait a minute. I just try to show you if you are going to plot vector into the two-dimensional space. So how the words are represented. Okay. So then I will start different, you can say, the techniques. Just hold on. Yeah. So after this one, fine. Yeah. If you look at the draw model, is not different. Okay. So I have to again run this code. Okay, fine. So just hold a minute. so it will take time. Okay, no issue. So hold on a minute, and meanwhile I will take the questions if you have questions, because it will take some time to load. Okay, so meanwhile, if you have any question till now, you can discuss, and once this will be loaded, I will again discuss the different techniques. Okay, or if you have question, you can ask. No, chat. Okay, fine. So some of the questions, similarity of cat and bark, why it is high. Yeah, the thing is that now we have a very limited data. Okay, so if you will see the that example, we have only 4 to 5 you can say the sentences. So getting the basically similarity, or the you can say the similarity between cat and bark is 0.3 is higher, because you have a very less amount of data and you are training your model on that data. So that is the issue. Okay. So if you have a huge amount of this is the you can say the demonstration for the explanation purpose only. But if you will run this code on a huge corpus of data, you will get different answers. Okay, you will get different answers. And now, if you have no question, then what I will do, I will try to cover the next concept. Okay, and then whenever it will be basically loaded into the memory, so I will discuss this plot. Okay, so I will keep this plot for the later. So now, after this word to vec technique and pre-trained embedding vector, so we have loaded one, you can say the pre-trained embedding vector from Google News. No, so now we have one of the popular word embedding vector Globe. So this is a global vectors for word representation, and this is developed by Stanford. Okay, and how this vector will be generated? This is very interesting. Okay, so how this vector will be generated, that we are going to see. So again, I will try to take one example, and that will be more understandable. Okay, so that meaningful, more meaningful. So see, we have two words now. The cat sits on the mat and the dog lies on the floor. So two sentences we have. And we have this co-occurrence matrix. What is the word co-occurrence matrix? Meaning is what? Word co-occurrence matrix with the window size of 1. So what this globe is doing, it just try to see. So window size of 1 means what? One word is before the target word and one word after the target word. So see, this the is coming before this cat. Okay, so just see, the cat we have one, and if again see, d will come with this on. No, so before this on, so on, for this on we have one, and d with this dog we have one. Okay, so one. D with mat we have also one, and D with the floor we have also one. So likewise, we can create one co-occurrence matrix. Okay, so by using this co-occurrence matrix, Globe will try to generate the embedding vector. So how, that we are going to see. So again, if you will see, we have a window size of 2. So this co-occurrence matrix, you can basically get it from the corpus. Okay, so two words we have to see before and two words we have to see after. Okay, and after getting this one, we have to calculate the probability. So how the probability will be calculated? So I just try to take again example. So Pij equal to Xij and summation of K Xik. What is the meaning of this one now? Let us suppose I again try to take forward on. So on, if you will see this on, you have a two basically occurrences with the no. So just see. So x on comma the, we have a two occurrences, and total number total occurrences of on with all words is how many times? If you will see, if you will count this one, 2 plus 1 plus 1, 4, 5, 6, 7, 8. So the probability value is 2 by 8. It means the probability value is 0.25. So this probability value we have, and how this will generate or will be used to get the embedding vector. So just see, it just try to calculate the probability in this fashion. So probability of ik, probability of jk equal to, this is the same formula you have. And if you are going to get probability of ik greater than probability of jk, it means the word k is much more related to word I than the word j. Meaning is what? It will be based on probability. And similarly, if you have a near equal to probability, word are equally related to word I and j. So like that one, just try to calculate the probability value. So meanwhile, I just try to see. I think it is now loaded into the memory. So I just try to run this code for you. Yeah, now see, if you will look at this two-dimensional plot of word, sorry, a different word. So if you will see this banana and yeah, this man and woman is very closer. King and queen is very closer. This prince and princess is very closer. Dog and cat is very closer. So like that one, you are going to get the embedding vector. And if you will plot it into the, it is a only two-dimensional space, and we cannot plot after this three dimension. But if you have a vector representation into the 50 dimensional vector, it means you just have to think about the 50 dimensional space. And the 50 dimensional space, one point will be there, and that point will represent that vector, that word. Okay, so based on that one, you can basically take one intuition that, so how the word embedding will help to uh, basically help us to identify the similar type of words. Okay, this is the concept. Now, uh, we were at this explanation. Okay, so likewise, you are going to get the probability value. Okay, so there are different mathematical concepts also. So I will suggest you to follow this reference. So if you want, you can go into the depth of this reference. You will get the entire concept related to this Google Colaboratory concepts. Okay, so sorry, this is Google Globe concept, so that you can get it from this reference, so that you can do. So I think, okay, fine. So I'll be left with 15 more minutes. Fine. So what I will do, I will try to again show you the output if we have a Google vectors. Okay, so Google vectors we have, and this is the output. This Google vector with this 50 dimensional, you can say, the representation. So now king is represented in this format, and similarly, if you will see this king, prince, queen, like that one, you are going to get the answer. Okay, and now I will cover this, at least cover this fastest embedding, because at the start I told to cover till BERT embedding vector. So based on the availability of time, what we will do, I will just cover this one, fastest embedding, and we will take questions from your side. Okay, so we'll discuss more on your questions. So now, what is this fastest embedding? Okay, so fastest embedding is very much popular, you can say. If you are working on the English language, this is fine. Globe will help you. Okay, so just wait a minute. Yeah, wait. Yeah. Why this fastest is very much important, and this is developed by Facebook AI research. Okay, so this thing is that if you have a English corpus, English data you have, so fine, uh, you can use Globe. Okay, but if you have a, let us suppose, Hindi data, or if you have a Bengali, if you have a Odia, you have a Kannada, you have a Tamil language, so how you are going to convert words into the vector format? This is the question. Okay, because it is now different regional languages. So what this FastText will do, it will support up to 104 languages. So 104 languages it supports. And I will show you how you can work with the Hindi language also. Okay, so as I said, this FastText embedding, one important point is, uh, in the previous entire discussion, whatever the discussion I had, so if you have play, plays, playing, okay, so let us suppose in your corpus you have a play, so you are going to get the embedding vector. If you have a plays, then if you are using any other embedding vector techniques, so it may possible that you are not going to get that vector. So one example only, okay. But in the FastText, what it will do is just try to calculate the vector by considering different anagram features. It means what? In the start of TF-IDF, I discussed we have a different anagram feature, 1, 1, so one word at a time, 2, 2, 2 word at a time, 3, 3 word at a time. Like that one, we have a fast text embedding. So what it will do is just try to use either SIBO model or the scriptgram model. So whatever the topic we just discussed, scriptgram model and the SIBO model. But one modification is that it just try to take the anagram features. It means it will not directly try to take the entire word, it will take the different anagram representation and then it will try to train the entire mod. It means what? If you have the apple, this is the start token, this is the end token, and 3 word at a time, if you will see, 3 word at a time. And likewise, it will try to use either scriptgram model or the SIBO model to try to generate the fast text embedding. Okay, so the concept is very same. Only one addition is it just try to take the anagram features. Now, after this many discussion, if I will show you, I will try to show you. Yeah. This is how we can utilize, you can create one fast text embedding vector. This is my corpus, and for this corpus we have used this fast text embedding with the vector size of 100, window size of 3, minimum count is 1. SG1 means what? Now we are using a scriptgram model. So likewise we are going to train this fast text model with our data set, and we are going to get the fast text basically embedding vector, and this is the representation, and this is the similar word. So that you can do for your one on word. But now let us suppose you have the fast text embedding, pre-trained embedding. As I said, we have a 104 number of different pre-trained fast text model for different languages. So if we have that one, so I just try to go with some of the Hindi languages explanation. Okay, then I will stop and then I will take questions from your side. So first of all, let's try to connect it with my Google Collaborate. Just hold a minute. Yeah. So now if you will see, I have one CCHI 300 VAC name. This is the word embedding vector, and that I have pasted here in my uh, drive. Okay, so that I just try to load it in the memory, and I just try to find the most similar word related to Bharat. Okay, now see if you will see. So the Bharat related to this Desh, Bharatya, Pakistan, Raj, Visv. It means what? It is related to the different, you can say the state or the country like that. Okay, so again you have a different way. So Raja, Mahila, and Purush. So those type of things you can do with the Hindi language also. And same concept you can do with the Bangla, Odia, Kannada, Telugu, any of the regional languages. Okay. So what I will do, I just try to show you one two-dimensional representation also. Let us suppose we have Bharat, Delhi, Samachar, Cricket, Khel, Acha, Badhiya, this type of words we have. And again, I just try to use the same pre-trained embedding vector and try to plot this embedding dimension. So now see. So the spelling of this is different in the Devanagari because I have used this one, okay, Lohit Devanagari. If you will use different, so you will get the same, basically different, you can say the representation. Okay. So if you will now see Delhi, Bharat, it is very closer. Cricket, Khel, it is very closer. Acha, Badhiya, very closer. So like that one, you are going to get the embedding vectors from fastest, and that you can do, and you can basically uh, utilize this fast text encoding, and you can also work on the regional languages. Okay, so that you can do. So I think I left with 5 minutes. So it's now time for question answer. Uh, I've prepared some more slides, more notebook, but fine. So I will stop it here, and I will try to take some of the questions from your side. Okay, so that will be more meaningful after. Sir, yeah. Can you please share your mail ID so that we can connect with you? Yeah, sure, sure. So this is my mail ID. Yeah, this is my mail ID. So I will, for the participants, if you are new to the NLP, so I will suggest you, uh, for if you want to do some of the uh, problem which is related to regional languages. Okay, let us suppose you are doing some of the problems of name entity recognition or the sentiment analysis of on the on the regional languages. Okay, so what you can do, you can start with the fast text embedding and BERT you have. Okay, so BERT also supports the multilinguality. So we have a multilingual BERT, if you will see. So we have a multilingual BERT also where we have a token embedding, positional embedding, and segment embedding. And based on that one, you just try to learn the concept. And one important point is, as I said at the start, Bank of River or the State Bank of India. So this BERT will try to give the different embedding vectors for bank. Okay. So based on the context. So this BERT is doing that task. Okay. So just try to explore the things. Okay. So that will be more meaningful. My reaction. Fine, fine, great. So you try to start work. This is good. So if you have any other question, you can write it. Yeah.
Uh, yes, sir. Go on, sir.
Yeah, if you have any other question, you can write it in the chat box and I can discuss on this basically question. And this notebook I will share with the organizing team, and you will get it from
this notebook I will share with the organizing team, and you will get it from there.
Yes.
Yeah, Vikas.
Yeah, Vikas.
So I think there is no more queries, sir.
Fine.
So participants, so if there is no query, we will conclude this session. We will join back at 5 again. So thank you so much, sir. Thank you for a wonderful session today. It was literally we were having these concepts of encoding and embeddings a while ago, but it was very much insightful. All the participants have now come to know what this embedding and encoding has to do with all the NLP and other tasks that we have seen earlier. So thank you so much for your time, sir.
Thank you.
So we are closing for this session.
Okay.
Thank you so much. Thank you all the participants.
Okay, thank you, Dr. Vikas.
Thank you, sir.